I know. I don't remember what I did yesterday.
All right. Trig graphs, yay! All right, we are going to first recall and graph the first 6 trig graphs: sine, cosine, tangent, cosecant, secant, cotangent. Then we're going to focus in on sine and cosine, and we're going to learn how to do what are called the phase shifts, the vertical shifts, things that you haven't done that you should have done last year. I'll be honest with you. I hated that I had to skip this section, but we had to get to conics. I was very, very important part that I go through. All right. So you do have to take notes, and then I will be doing 4 of the graphs on the sheet that I handed to you. Make sure this is good. All right. So let's go over what sine of x looks like. And you could always, by the way, and I should have told the other class this, but you can always make a chart. You know, you can say, what's the sine at 0? What's the sine of 0? You should all know that.
0.
Okay. And then you could do pi over 2, which is 90 degrees. What's the sine at pi over 2? 1. Okay. And then you could always make charts to help you remember, especially on today's, if you're like, I can't remember, what do I do? Plug it in. That'll help you out. But here's basically what it looks like. Your sine graph has what's called an amplitude. Amplitude is halfway between the distance of the graph up and down. So the sine is, and the amplitude, I'll tell you where that's located, but the sine is always 1 and -1. Okay. And then I want you to remember this magic number 5. You need 5 points on a sine and a cosine graph, 5 points. Okay. You will start at the 0, and then you'll make 4 more marks after that. So a total of 5, though. 1, 2, 3, 4, 5. That's where the 4 marks plus the 0 one. A sine has a period of 2 pi. And if you don't remember what period is, period would be one curve of sine, one cycle, one exact cycle, then another one, then another one. It keeps repeating. And so the way it looks like it would go, sine of 0 is 0. Sine at pi over 2, this is pi over 2, would be 1. Then sine at pi, back to 0. Sine at 3 pi over 2 would be -1. That's 270 is -1. And then sine back to 2 pi or back to 0. It usually makes this S shape or snake shape. I don't know, however you want to call it. Okay. This would be considered the period, which is one cycle. And this right here is the amplitude. So good old sine. We love you. Just real quick, what would the domain of this one be? How wide is this graph getting?
All real numbers.
Negative infinity and infinity. Okay. What's the range though? How tall is it? It stays between -1 and 1. Okay. All right, so there's sine, memorize it, love it, think 5 points. We need these 5 points. It's always this sideways S, goes down, up, middle, down, up. Okay.
This is like a...
Yes. Very good, Jed. He's here all day. He's here all day.
I'm here literally, I'll be here for a while.
All right. Now, cosine x is different. And again, if you think about making that chart, the cosine at 0 is what? Where does that start? What's the cosine at 0? 1. Your x value is 1. So now it still goes as high as 1, as low as -1. You still make your 5 marks, including the first mark. So 1, 2, 3, 4, 5. It still has a cycle of 2 pi. So it'll go like this. It'll go cosine at 0 is 1, 2, 3, 4, 5. Cosine looks like what they call a cup. Some people call it a cup. It still will continue that pattern and continue a pattern, but
What does it say for that period on the top one?
period 1 cycle. Sorry. 1 cycle. Actually, I spelled sile.
Sorry.
Thank you. Cycle.
Okay, we all make mistakes.
I can't spell. Okay. Moving on.
Neither can Dan.
Let's do tangent. So tangent is a little different. tangent, if you recall, has undefined parts to it, right? If I took the tan of what? Where is it undefined? Yeah, where is it undefined at? At 90 and 270, right? Okay. So at pi over 2, and then here's pi, and then at, we'll say 3 pi over 2, it's undefined. There's asymptotes here. Okay. And your tan graph looks very cubic, actually. So I'm actually going to just draw the half of it since my graph is starting at 0. It goes like that. But this one, I'll draw a full one. Tan looks like this. Okay, so that would be, you can obviously know that it's going to go that way too. But this is different in a sense of its period is not 2 pi. One cycle of tan is actually pi. The period for tan is pi. It has one complete cycle of pi, and you can see from pi over 2 to 3 pi. Yeah. Then amplitude, how tall is this going? How infinity. Some people will say none, but it's infinite. All right? So there's good old sine, cosine, and Mr. Tangent. Now let's do their reciprocals, which look fun. Also 1 and 1. Amplitude is here, and then the cycle is still 2 pi. One period is 2 pi. Sine and cosine are pretty much pi, and the amplitude is infinite. Okay? Yes, Jack?
But like, is cosine, like, and sine, like, do they have the same cuppy kind of thing? Like, does it look like it just moved over?
Yeah.
Okay, good.
Mm-hmm. Okay. So now let's talk about cosecant. So cosecant is the reciprocal of sine. You all agree that? Okay. So what you would do is I would draw sine. So I would actually make my 1, 2, 3, 4, 5 marks here. I would draw sine, but actually, so go dot, 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 and I would make those dashed like that. I'll tell you why in a minute. Your cosecant, the reciprocal of that is actually parabolas, one right here, and then one right here. And then there are these asymptotes right there and there. That would be one cycle of cosecant, an up and a down, an up and a down, an up and a down is one cycle of cosecant. Okay, and that's the reciprocal one. The reciprocal of sine. What would be the amplitude here? Infinity. Yeah, it's going off. What would be the period? Still 2 pi. Okay, you got to have an up and a down, still 2 pi.
I don't know why isn't it just pi?
Because you need an up from 0 to pi over 2, or pi. The asymptote is here, pi, yeah.
Doesn't split it down the middle.
It's like,
Doesn't what split it down the middle, honey? I'm sorry, what you're saying.
Like for tangent,
Yeah, but it has to have an up parabola and then a down parabola to be one cycle.
Okay.
Okay? Yes.
it's like undefined at like the 0 parts.
Yeah.
Like 1 over 0, right?
Mm-hmm.
Okay.
You're so smart. Both of you, brilliant. Y equals secant x. So now we're the reciprocal of cosine. So what I would suggest you do again is draw a cosine graph. As high as 1, as low as -1. Make your marks. 1, 2, 3, 4, 5, 2 pi right here. Pi right here. And then I go to draw my cosine. My cosine starts at 1, 1, 2, 3, 4, 5. Make it dashed. Okay. So this one is going to look a little weird. You're going to have asymptotes here at pi over 2. And there's one. At this bump, if you were to draw the actual U, half of it would go into the negative. I'm just going to draw the positive part. So it'd go half of it would show, then a down parabola, then the other half that would be considered one cycle of cosecant. I'm sorry, of secant. All right. And then one more. These three, by the way, we're not focusing on them today. I'm just moving it. Jed, I'm just moving it up.
How do you know where the asymptote is?
Well, think about it. Where's the reciprocal? The reciprocal to secant is 1 over cosine, right?
Mhm.
And so if cosine was 0, I'm sorry, if cosine was, when's cosine 0?
270 and 90.
Okay, so, and so you would be undefined because you had to have 0 on the bottom, wouldn't you?
Mhm.
So that's why here at 90 and 270, we're undefined.
Oh, okay.
Okay?
Which is why.
All right, last one, cotangent x. So let me just draw this one for you. There is, it looks just like tangent, and you know how tan does that cube dance? It has a cycle of pi, and then we'll go in half, pi over 2. Instead of us going this way, the cubic part, we go the opposite way. Do like that. There's cotangent. Okay? And again, still has a period of pi. Amplitude is still infinity. All right, but we are going to so focus today on just sine and cosine, just those two. And that's what all of your homework will be about today. Just
So,
sine and cosine.
so it's like flip? But
Yes, yeah.
Why does that have like a full, like, 10 has like half of it?
I was just showing you the 1/2. I'm sorry, I showed you a half of a period on the other one.
Is that, where's?
This one is one full period. There's pi is one full period in cotangent and in tan.
Okay.
Okay, I just started my graph, I think, for tan at 0 or wherever I started it. And I was showing you the other half of it.
Pi is an asymptote on both? of
Yeah.
them?
Mhm.
Okay.
No, I think, no, pi over 2 is the asymptote on the one.
Wait, oh,
Pi is a 2.
oh, okay.
Okay, so this cotangent has an actual value at pi over 2. But at pi over 2 on this, on tan, it's, remember, it would be undefined. But then if I flip undefined, I would actually have the value of 0,
Okay.
if you remember.
90.
Right.
0, or, undefined.
Okay, so the general forms of sine and cosine. There are 2 of them. Y equals, leave a space. I'm going to use some colors here. There's methods to my madness. Okay, so we'll do A in front of the sign, B next to the X, C after that one, and then green. Hello, gray. Where's my green? There's my green. And then plus D. Okay? And then I want you to write it again with a cosine. And use the same colors if you have colors. If not, just put a letter there. And I think the colors make sense to me, so that's why I do colors. So this is just like when we did translations on the graphs. Translations meaning we shift right and left, we shift up and down, we shrink it, we expand it, all that stuff, okay? Yeah, all that fun stuff that we did. All right, so let's go over what all these letters mean. A stands for amplitude. Amplitude, that is how high the graph is gonna go up and down, how high. It'll go as high as 1, as low as -1. It'll go as high as 4, as low as -4. It could, stretching it, okay? Think of the sine graph right now and then think stretching it, okay? That's what A stands for. The number in front of cosine and sine is how high up and down it goes. The number in front of your X, usually it's 1, but if it is a 2 or a 3 or maybe a pi or something like that, that is the period of the graph. And you have to do 2 pi over whatever that number is. If it's 1, your period is 2 pi. But if it's another number like 2, then your period would be pi, meaning one cycle of the graph would only go to pi. Or one cycle of the graph would only go to pi over 2. I mean, it could be, we're going to really compress it and just make that sine graph go like this, squeeze it. So this is the period of the graph, how it should go to 2 pi if it's a sine or a cosine, but sometimes if I put a number here, it'll only go to pi, or it'll only go to pi over 2. It won't, you'll have a bunch of them. You'll be going like this, up and down and up and down, up and down, up and down, up and down, okay?
That's basically how long.
Yes, one cycle is. This is, remember, this is one cycle. Okay?
What's that mean?
You'll either have an S or you'll have the cup. That would be one cycle of sine. That would be one cycle of the cosine. All right. So now the C. So listen, this is new for you. This C is your phase shift. Okay, but you have to do something extra. The phase shift moves the graph right or left, which makes sense. Remember the whole thing when I taught you last year, like if you're with the parent, you move right and left. If you're outside the parent, you go up or down. Same thing, moves right or left. However, you need to set the entire parenthesis equal to 0. And then that will tell you where the graph starts on the x-axis. Set that whole entire parenthesis equal to 0. Because sometimes, I don't think in this worksheet, but sometimes if they had 2x plus pi, you'd have to set that whole thing equal to 0 to tell where it starts on the graph, on the x-axis graph. All right, then last but not least, D is what happens when you're outside of the parent? Where do you always move when you're outside the parent? Up or down. So think of your sine graph now going up, maybe, or going down, maybe. So that's what that D does. It's called the vertical shift. All right, so we're going to practice this. Oh, I should say up or down. All right, so I am going to do 4 problems for you. I think if we do all these 4, you should be good. I'm going to start with number 2 on that little worksheet there that you have. Is my Gabe still in here? Yeah, Gabe. Okay. You got this, Gabe. Ooh, wow.
It's a TI-84.
That's TI-84. It really is. Could you imagine if they come out with a TI-84 that has Wi-Fi? I'm sure they do. I'm sure they will.
It's already expensive enough to have Wi-Fi.
All right. Y equals 4 sine pi x. Anybody know just in their head right now what this kind of is going to look like? Is it an S or a cup right now? It's an S. What is that 4 going to make it do? Like super tall and super short. That pi is going to determine the period. So here we go. We'll start with amplitude. It's going to be 4. It's going to go as high as 4 and as low as 4. The period for sine and cosine is always 2 pi, but you divide by whatever the b is next to the x. So we're going to divide by pi. It means I have a period of what now? 2. Just 2. Okay. And then I think all the rest of the stuff we don't have. We don't have a reflection. We don't have a vertical shift. We don't have a phase shift. Well, I mean, we do. You could say set that equal to 0, but really that's just going to be 0. So nothing else is there. So this is really a nice graph to start off with. So you're going to go as low as 4, 1, 2, 3, negative 4. You're going to go as high as 1, 2, 3, 4. Okay. You're going to have your 5 points, including the one on 0. So 1, 2, 3, 4, 5. This is 2 pi. This would be pi in the middle. And then obviously pi over 2, 3 pi over 2. And then you draw me one cycle. All I want is one cycle in this lovely graph. So you would go down. Always sine at 0 is 0. Sine at pi over 2. Then you go up to 4. Back down. All the way back down to negative 4 now, and then up. I just need one cycle of pi, of sine. Sorry, of pi, of sine. Is that hard?
Nope.
You're going to do that on that front page, so that's the easy part.
So we don't need to find the reflection phase shift.
There is no reflection. There's no phase shift. There's none.
So
None.
if you know,
Just leave it blank.
it's flag.
What does the period determine?
The period determines one cycle of sine.
Okay.
You have just done one cycle of sine. You don't need to keep drawing sine after sine. We know it repeats. It's repetitive. Okay, Jack?
If the period was pi, is that like making it like
Exactly. If the period is pi, think of this S right here going right here. It would literally squished. Exactly. It would go "Whirr," like that. Yeah, I love our noises. Yes, Ashlyn. There is no reflect. We're going to do one with reflection.
What would be the difference between a period of 2 and a period of 3?
no calculation?
You literally go to 2, and then half that distance would be 1, and then you would have a half. You wouldn't have pi. You wouldn't have pi. Okay, so here's the number 10 we're going to do now. I'm going to do it right now. Or is this one? No, I'll do it. I think I do one like it. Is it this one?
Yeah, it's that.
Okay, good. This is a good one because it's the negative, but this is the one that screwed me up in the other class because these negatives always get to me. All right, so let's go through all this right now. So our period is always 2 pi divided by the b. The b is 1, right? So it's just 2 pi. Great. So I know it's going to be a sine in one curve of sine, one sideways s from 0 to 2 pi. Cool. Well, actually, I don't know it's from 0. My amplitude, what's that? What's the number in front of sine and cosine? -1, but really you just take the absolute value of it. So it's going to go as high as 1 and as low as -1. Okay. Is there a reflection? What do you think? Why yes? Because there's a negative, and that means reflection. So that means instead of going like this on the graph, where are you going to start? Instead of going up, middle, down, you're going to go down. Okay, well, that was terrible, but you know what I mean. All right. Then phase shift. Okay. So phase shift means have I moved right and left? And you can even tell right now, haven't you? And if you set this equal to 0, what you going to get?
Negative pi.
You're going to get -pi/2, which you kind of knew. Okay. This is where you start on the x. You start there at -pi/2. One more thing, vertical shift. This one has all of them in there, so this was a good one. It's up 1. Okay. So now here's what I want you to do when you have a phase shift. I want you to show me one full cycle. Well, what does that mean? That means you have to show me from -pi/2 all the way through one full cycle. One full cycle of pi would be adding 2 pi, right? Would be one full cycle. But when I add 2 pi, aren't I really adding 4 pi/2 to this fraction? What's 4 pi divided by 2? 2 pi.
Oh, you're just making the denominator
Right. And so then what would this be? What's a -pi plus 4 pi make?
3 pi.
Okay, so here's what I've just done. This is where you start on the x. This is where you end. And that would be, on the x, that would be one full cycle. That's why we do that. You only have to do that when there's a phase shift. You only have to do that when there's a phase shift. So let's see what this looks like. This is going to be interesting. Hopefully I won't screw it up like I did the last time. Right, Gabe?
Yeah.
I'm waiting for Gabe to be like, yeah, you screwed up big time, lady. All right, so let's start here. I have a vertical shift of 1. Let me start there. So I'm going to make a dashed line at 1. Why do I make that dashed line? Because I've shifted this x-axis up now. That's the midline of my graph. Another word for vertical shift is midline. From that midline, I'm going to go my amplitude. So my amplitude is what? Up 1, down 1. So really, my graph is as tall as what? 2 and goes to 0. Are you with me so far? Okay. My phase shift starts at -pi/2, so I'm actually going to start here in the negative side. And again, I want to create 5 points, including this one. So here, we'll count this as 1, 2, 3, 4, 5. What's that end right there? And again, how did I find that? I added 2 pi. I added 1 cycle. That's all I did. I know that I have to have my S fit in here. I have to have my S fit in here. Now, this might be helpful to you. Draw yourself a box right here to here, to here, to here, to here. Your graph lives in that box. That's where the graph lives. The graph has been shifted up and over to the left. Does that make sense? Up, over to the left. All right, and then one more thing before I start drawing, because right now I want to draw my S. Oh, again, I'm trying to draw that, but I don't want to draw that because I have this. I'm not drawing that S starting at top. I'm going to go in the middle and start down. So I'm going to go middle at negative pi over 2. Then I'm going to go down, back to middle, then where? Up, then where? Back to middle. This is the reflection of sine. I have shifted it up 1. I have shifted it over left, pi over 2. That's what the graph looks like. We just drew 1 cycle. Whew, that's a hard one. Hard but good. Goodie but oldie. Let's do another one. And then actually only 2 more left. We got this. Number 16. There's so many, I know. Should I give them all of them, Gabe, like I gave you guys?
Yeah, no, definitely not.
All right, so let's go through this and think of this again. What's my period, y'all? Did anything happen there? So what is it? 2 pi. What's my amplitude? What's the number in front of cosine? 1. Is there a reflection? Nah, there's nothing here. What's the other thing they have? Phase shift? What's a phase shift? Pi over 4. That is where you start. Okay? 16. Is there a vertical shift? Up how many? 2. This is the cosine graph. So again, it's that little, V, not V looking thing. I don't know what to say. Parabola, maybe something like that. All right. So let's do this. When you have a phase shift, I need you to add 2 pi to it because I need to see 1 cycle. What would 2 pi be if it has a denominator of 4? 8 pi over 4, which means I would be at where? Okay, so this is where you start. This is where you end on the X. Does that make sense? That would be 1 cycle for me. I need to see 1 cycle of sine, of cosine, 1 cycle. I don't want to see half a cycle. Okay, so now let's draw this here. My vertical shift is at 2. Okay, so let's go up there first. I kind of work backwards, I guess. 1, 2, make a dash. My amplitude is as high as 1, as low as 1. So what number am I really at here and here? 3 and 1. Okay. My phase shift starts at pi over 4. So actually, I'm not going to choose this to be my first mark. I'm going to choose here to be my first mark, pi over 4. And I'm going to create 5 total. So 1, 2, 3, 4, 5. Where is this ending? 9 pi over 4. Start at pi over 4, end at 9 pi over 4. Anybody happen to know what's in the middle between pi over 4 and 9 pi over 4? How did you know that? Yeah, 1 pi plus 9 pi makes 10 pi's. And 10 pi divided by 2 is 5 pi. So right in the middle, 5 pi over 4. Okay, so what does that mean? I am living, my graph is living, let's see, I've been shifted. My graph is living here. Does that make sense? My graph is living up in there. It's been shifted up, it's been shifted over. I need 1 full cycle of cosine right in that shifted box right there. So at pi over 4, do I start which one? Upper, middle, or bottom? Start up, go to the midline, go down, come back to the midline, go up, and then kind of make a little hook at the end so there. That would be the cosine shifted over pi over 4 and then shifted up 2. Yes, no? How are you feeling? Yes. All right, one more. The other class asked me to do, I was going to do number 18, but they said, no, do 20. Do you want me to do 20? 20 looks pretty, 20 or 18? I'll do 20 because 18 helps Gabe. Y equals 3 cosine of x plus pi over 2 minus 2. Can you right now just think of what this graph is going to look like in your head, kind of? What's the 3 doing to the cosine u? What's it doing? It's pulling it. What's the minus 2 doing to that u? Bringing down. What's that pi over 2 doing? Shifting left. So you kind of should have a visual of what's happening now. I've stretched it. I've shifted it down. I've made it go left. Okay? Keep that in your head as we begin to fill this out. So what is my period? Still 2 pi. There's a 1 in front of here, so you just do 2 pi over 1, 2 pi. Your amplitude is 3. Your phase shift is, set that equal to 0, it would be negative pi over 2. That is where you start. While we're here, let's find out where we end. Add 2 pi or add 4 pi over 2. What's that make? That is where you're going to end. Mrs. Seta, why are you adding this? Because I need one full cycle. And 4 pi divided by 2 is 2 pi. There is always one full cycle of cosine is 2 pi, one full cycle of sine is 2 pi, okay? We're just starting somewhere different, that's all. All right, and then what else do I got? There's no reflection, right? Vertical shift, where's that? Negative 2. All right, so let's graph this and then we will be done. And hopefully you'll be better at these than even me. So starting at negative 2, 1, 2, I'm going to make a dashed line. That is what we call my midline of the graph. That's where the middle is. I'm as high as 3 units from that midline. So go up 3, 1, 2, 3. So I'm actually at 1. And then I go down 3 from there. 1, 2, 3. What is that? 1, 2, 3, 4. Negative 5. Okay. And then I start at negative pi over 2. So I'm going to let this be negative pi over 2. And I'm going to create 5 points, including this one. So 1, 2, 3, 4, 5. What's that last one going to be? 3 pi over 2. You are living, if you want to draw a box, because I think the box helps me out, you are living here. Your cosine graph is living right inside there. It's shifted over, it's shifted down, and it's kind of compressed a little bit. All right, so now, remember your cosine graph. We don't have a reflection, so remember it goes 1, 2, 3, 4, 5. It looks like that, okay? So at negative pi over 2, I'm going to start where? Up, middle, or down? Up. At 0, I'm going to start in the midline. I'm going to go to the midline. Then at this next mark, I'm going to go down. This next mark, I'm going to go back to the middle. And then at the last one, I'm going to finish up. That would be 1 cycle of cosine. And that, my friends, is what you missed last year. And you're sad, I know. You did, no, all I did was teach you the basic graphs because we didn't have time. And I'm actually debating on doing it this year, again, because of my time, of course. All right, so Gabe was lying to you, of course. You only have to do evens. And I just did 4 of them for you. So that is, I think you have a grand total of 10, maybe, that you now have an hour, 50 minutes to do. Can you flick on that light for me? However, my people who need to take a quiz need to take a quiz. People with projects need to do projects, hand in HWQs, all those fun things that need to be done.